The most common type of hydroelectric power plant is an impoundment facility. An impoundment facility, typically a large hydropower system, uses a dam to store river water in a reservoir. Water released from the reservoir flows through a turbine, spinning it, which in turn activates a generator to produce electricity. The water may be released to meet changing electricity needs or other needs, such as flood control, recreation, fish passage, and other environmental and water quality needs. Diversion. A diversion, sometimes called a run-of-river facility, channels a portion of a river through a canal and/or a penstock to utilize the natural decline of the river bed elevation to produce energy. A penstock is a closed conduit that channels the flow of water to turbines with water flow regulated by gates, valves, and turbines. A diversion may not require the use of a dam. Pumped storage. Another type of hydropower, called pumped storage hydropower, or PSH, works like a giant battery. A PSH facility is able to store the electricity generated by other power sources, like solar, wind, and nuclear, for later use. These facilities store energy by pumping water from a reservoir at a lower elevation to a reservoir at a higher elevation. When the demand for electricity is low, a PSH facility stores energy by pumping water from the lower reservoir to an upper reservoir. During periods of high electrical demand, the water is released back to the lower reservoir and turns a turbine, generating electricity. Sizes of hydroelectric power plants. Hydropower facilities range in size from large power plants, which supply many consumers with electricity, to small and even micro plants, which are operated by individuals for their own energy needs or to sell power to utilities. Large hydropower. Although definitions vary, DOE defines large hydropower plants as facilities that have a capacity of more than 30 megawatts MW. Small hydropower. Although definitions vary, DOE defines small hydropower plants as projects that generate between 100 kilowatts and 10 megawatts. Micro hydropower. A micro hydropower plant has a capacity of up to 100 kilowatts. A small or micro hydroelectric power system can produce enough electricity for a single home, farm, ranch, or village. How it works. Generally speaking, the scheme of a power plant includes a barrage, a dam, or a sleeper that intercepts the watercourse, creating a reservoir that can be a reservoir or a reservoir. Through adduction works, canals, and diversion tunnels, water is conveyed by penstocks from the dam to water turbines, which rotate in order to generate mechanical energy, which is then converted into electricity by the rotating electric generator. The water sets the turbines in motion, thereby generating mechanical energy. The water is then released into a discharge channel, through which it is returned to the watercourse. The turbine is directly connected to the rotating electric generator alternator, which converts the mechanical energy received from the turbine into electricity. How it works. Generally speaking, the scheme of a power plant includes a barrage, a dam, or a sleeper that intercepts the watercourse, creating a reservoir that can be a reservoir or a reservoir. Through adduction works, canals, and diversion tunnels, water is conveyed by penstocks from the dam to water turbines, which rotate in order to generate mechanical energy, which is then converted into electricity by the rotating electric generator. The water sets the turbines in motion, thereby generating mechanical energy. The water is then released into a discharge channel, through which it is returned to the watercourse. The turbine is directly connected to the rotating electric generator alternator, which converts the mechanical energy received from the turbine into electricity. Hydropower plants are divided into three macro categories, depending on the type of plant used: run-of-river power plants, reservoir power plants, and storage power plants. Flowing water power plant. In run-of-river power plants, the natural flow of a river or stream is used directly, the water from which is channeled to the turbines and then fed back into the natural flow, downstream of the plant. Central basin. In a reservoir power plant, water from one or more streams accumulates in a reservoir, either natural or artificial, created by a dam, and then flows downstream to drive turbines and finally be fed back into the river. Thus, in this kind of plant, power generation and available water can be controlled both by flows and quantity. Accumulation power plant. Storage or pumped storage power plants feature two reservoirs at different elevations, one upstream and one downstream, the second of which serves as an energy reserve. This allows for a dual regime. At times of lower energy demand, the water, once falling into the downstream basin again passing through the turbines, and generating electricity, can be made to flow back into the upstream basin, using the same turbines acting this time as an electrical pumping system. Natural accumulators. In storage power plants, therefore, water can become available again for electricity generation when demand is greater. In this sense, the power plant can work in a closed cycle. It is not necessarily tied to the flow of a watercourse, and functions as an energy accumulator that can be converted into electricity.